Today is the last class, no?
This is the last class.
Then how can I keep in contact with you after this?
Yeah, I'll tell.
Huh?
Yeah, I'll tell you.
Oh, okay.
Yeah, my screen is visible.
Yes, sir, it is
Yeah.
visible.
So anyway, today there is no new lectures. So all the problems will be based on the previous lecture sessions, and I have chosen few problems so that all the lessons from different weeks will be covered, and that we will get to see that what are the problems, and probably I will help you to sort of give you a review of the review of all the lectures and also the problems. So it is not possible to cover all the week's lessons in a single assignment sessions, but nonetheless it is always better to do something. Okay, so we will wait for 2 or 3 minutes so that others could join, and then we'll start. In the meantime, I'll be happy to take any questions from the previous sessions, or if not, then only. Okay, yeah.
No, I have a not a doubt, but a question regarding that Jacobian method.
Yes.
I mean, when to apply that and when not to, I'm not figuring it out.
So Jacobian method is something like when you are, let's let's keep the discussion fully mathematical first. So Jacobian method is useful when you are trying to transfer the coordinates, or you want to change the coordinate systems into different things. So when you are talking about pressure, volume, temperature, entropy, so these are kind of variables. Okay, so variables of different free energies. So there are four kinds of free energies we got to know. One is internal energy, one is Gibbs free energy, one is Helmholtz free energy, and one is enthalpy. So our aim is to write those free energies which are observables, right? Free energies are observables. So to know those observables in terms of those variables which are SPTV, entropy, pressure, temperature and volume, so to know those things, sometimes it is handy to know some things beforehand. So that's why we have to do this kind of coordinate transformations. So Jacobian transformation, strictly speaking, is something related to when you are transforming the coordinates. Let's say you are doing the coordinate transformations from xy to x prime y prime, and how these xy will be related, the coordinates in xy coordinate systems will be related to the x prime y prime coordinate systems. To know that, you have to get to know this Jacobian. So Jacobian is something like when you're trying to know the coordinate system in xy y prime, x prime y prime, then that is actually basically Jacobian times the coordinate systems in x and y. So different kind of formulations. So Jacobian is nothing but is related when we are trying to do the coordinate transformations. Is this clear? This part is clear?
Yes.
Okay. So now in thermodynamics, the coordinate variables are SPTV, entropy, pressure, temperature and volume. So we have to play around those things. So how many pairs of coordinate systems you can get? It is 4C2, that is 6. So there can be 6 kind of Jacobian, and to know that Jacobian, but more than 6 also possible, right? Because if you want to know from SP to TP, then there is only one kind of thing. You are fixing one thing there. So these things are quite useful. So that's why Jacobian is interesting. Now we actually got the thing. So Jacobian is nothing but a matrix method. Okay, so we are doing some matrix algebra. So if you follow the lesson of Jacobian method, you can get some idea that what you are doing, you are writing in the numerator the thing is delta, let's say xy, and in the denominator delta capital A, let's say AB, then it is written as del x del A and del y del x del A del x del B, and in the next row that will be del y del A del y del B. And now you are doing the in some determinant form and you are getting all those things. And now if you fix one, let's say if you do y equal to B, then you are getting del x del A at constant B. So this kind of manipulations, it's just about matrix manipulations and then getting the determinant, that's all. But if you have to know, like if you want to interpret it geometrically or physically, then it is nothing but coordinate transformations. Okay.
Okay, sir.
Okay, I have so many problems today, so let's not wait for more. Let's not wait for more. Let's start the session, and because I have more than 20 questions today, probably. So basically today some questions will arrive which have been derived earlier. So I will take you from the the previous ideas, and I will try to solve those, and probably I will just flash the questions once and you will try to do that first, and then I will try to help you. Okay, just start the
Okay,
session.
sir.
So this is the last problem solving session of the course named Basic Thermodynamics, Classical and Statistical Approaches, and the instructor of this course is Professor Arnab Mukherjee from IIT Pune. And this is you have probably known me now that I am Dibyendu. This is I am a PMRF or Prime Minister Research Fellow at IIT Kanpur, and I am doing my research in the field of physics. To know more about me, you can visit my website. There are few contacts. My email ID is there. You can contact me for any kind of queries, any kind of research related queries, and you can find my current research interests there, and also like the research topics that I have worked on or I'm working on. So, and also it is like I have said earlier, I am doing my research in non-equilibrium statistical mechanics. So probably this is just one step, one advanced step more. So if you want to do your research in this kind of non-equilibrium phenomena, so you can look at my website. And this is the YouTube channel where I keep on posting my YouTube videos. Probably till now I am posting all the YouTube lessons or this lecture or problem solving sessions there. There is a dedicated playlist by the name of this course, NPTEL and CY07 and that stuff. But I will in future I will also post some other, if I take another NPTEL live sessions, I will post those things also on this YouTube channel, or if I get some cool research videos, I will also post that. That will be helpful for the new generations or new generation young physicists or chemists or young researchers. Okay. And I will be highly thankful to you if you subscribe my channel, if you like my content, and if you leave a like or comment for my videos. Okay. So
I have subscribed.
okay, thank you so much. Okay, so let's just start by starting this problem. So these problems are very easy. You have to do it very quickly. I have just flashed it. So this problem says, is the following could be the total derivative of an equation of state, and it is given by this 2 nRT by v minus nb squared dv plus r. So Totagato, just tell me, is it correct or not? Let me just check that my video, I'm recording the videos. Yeah. Totagato, quick guess. Any guess?
in the right hand side there should be an equation like thing, no? It is just
Yeah,
a
this is just dp. So whenever, so for the equation of state it is written as p is a function of p of t, v, or n. So
okay.
so there is dp in the right hand side, so dp is equal to this thing. So
Then all right.
all right, let's check then. My answer is no. So
No.
this is p is equal to p t v n, and you can see this is an let's say you can write like p equal to v minus nb by rt. This is the equation, right? There is no other thing. Now we can write p rt by v minus nb. Now it is always written dp as del p del v at constant tn. We will not vary the n here, plus del p del t at constant v n and dt. So what is del p del v? Then constant t and n will be rt by v minus nb the whole square minus 1, right? Right? And del p
Yes,
del
sir.
t is r by v minus nb. So this is the thing, and this is not coming here, right? So if you substitute this now,
As a total derivative means exact differential.
yes, that can be written as like that.
Then no. I thought total derivative means
So because there
something
is, if
else.
you take is now to write it, now if you write to check it, this coefficient, this is m and this is n. Now if you do this del m del t, you get like, let's say, let's do this first. This is minus r v minus nb square, and if you do this del n del t del v, then minus r v minus nb square. So these are exact differential, right?
Yes.
But if you do this, these two things, let's say, I'm saying it m prime, m prime, n prime, but del m del n del m del t is not equal to del n del v, right? So this is not exact differential. So as you have just rightly said, Tathagato, that to write it as total derivative, we have to, this m and n has to be exact differential. Okay.
Okay, sir.
Okay. Okay. Now tell me, these are very easy questions. This is at the end of this lecture. Which of the
This
following,
is option.
which of the following quantities, Q, which is heat extracted, W, work, minus PdV, U, G, sum to 0 around a thermodynamic cycle? Please answer.
This is option A. Damn sure.
Option A. Yes.
Any day.
Yes.
Any
Yes.
day.
Yes. So
State function.
yes. So quantities to be 0 around a cyclic path, they need to be path function, right? So this is starting from A and then again coming back to this. Now Q, heat extracted, W minus PdV, all are, sorry, this will be state function. State function in bracket path independent. So this will be path function, and U, G, A and F, sorry, A, U, G and H, these are state functions. Okay, so this is the previous. Now question number 3 says pure membranes of dipel something like lecithin, some big name, let's just ignore it, are models of biological membranes. They melt at Tm, melting temperature equals to 41 degrees centigrade. Reversible melting experiments indicate that delta Hm, the change in enthalpy, is 9 kilocalorie per mole. Calculate delta Gm. What will be delta Gm?
Delta Hm minus T delta Sm.
T delta Sm. What will be that?
Sm is dq reversible by T.
Yes. And what does enthalpy says about this thing?
This is a positive enthalpy.
Yes. Can we write this? Delta S delta Hm by Tm, because this is the change in heat, because this is Hm is U plus Pv, and which is actually talks about the change in heat, right? So if you write that, then delta Hm will be Tm delta Sm. Now delta Gm, what is delta Gm? Delta Hm minus
T delta Sm. T delta Sm.
T delta Sm. So what will be delta Gm then?
Oh, 9 kilocalorie.
No, it is 0, right?
Delta Hm.
Yeah, because delta Hm minus Tm delta Sm, which is delta Hm again. So
Oh,
this
acha.
is so it is 0, right?
Then first one, can you explain once more?
So what is enthalpy? Enthalpy is U plus Pv, right?
Exactly.
Okay. Now if you follow the previous classes, for the reversible cases, Q is delta Hm. If you follow the previous classes, there is some relations for the reversible cases. Now you can write Q as, and reversible cases.
So we are replacing Q by delta Hm.
Yes. That's the thing. Because how the heat change will be there, if there is change in internal energy, and if there is external work, which is written is U plus Pv, right? So if you do that, you will get the heat. Okay. So okay. Now this problem says, for the reversible boiling of 5 moles of liquid water to steam at 100 degrees centigrade at 1 atm pressure, calculate Q, and also comment on whether W, which is work done, positive or negative. Do this.
It is given that reversible boiling.
Just reversible means you just there is no dissipation that much.
So can we think in that way that here liquid water is getting converted to steam? So latent heat comes into the picture. So temperature remains constant, isothermal process.
Yes, isothermal is there because it has to be isothermal, because when the state is changing there has to be isothermal, right? So
The
you are in right
temperature.
track. We have to calculate the latent heat, and if you calculate the latent heat, that is Q, right?
Same thing.
So calculate the latent heat.
Okay.
I'll give one number, that is the latent heat of water is 540 calorie per gram. Now calculate it.
Will it be given in exam or just have to remember?
Some I don't know because that is fully dependent on the professor who is the instructor, because we do not know how this course is running, because we are just problem solvers. We are just helping you guys to solve the problems.
So it is better to remember the water
It
related
is
quantities.
I hope that these questions or these now values will be there, because there is no I because I think there is no place of memorizing few values and then use that as an evaluation criterion for students. So anyway, just solve it. Hi Gaurav. So Gaurav,
Hello.
hi. So we are actually solving this problem. Problem number 4. We have already solved 3 problems. The problem says that for the reversible boiling of 5 moles of liquid water to steam at 100 degrees centigrade and 1 atm pressure, calculate Q and comment on whether W is positive or negative. And Tathagata just said that he will use the concept of latent heat to to calculate all these quantities. So that's all we are here up to this point. So you you will also please solve this, and after that after after that I will solve it. It shouldn't take that much time. It shouldn't take that much time. Okay. So the latent Rate of vaporization for water is 540 calorie per gram. So if there are 5 moles of water, so required heat is 5. Now, what is the molar mass of water?
18.
18, right? So 18 times 540, and the unit will be calorie. So that 18 what? 18
Gram per
quintal.
mole.
Okay. I have asked you what is the molar mass. Your answer should be 18 gram, right?
Okay. Okay.
Sometimes, like, I just want you to give one thing. Sometimes we neglect these units, but it is quite important to know those units precisely, because we remember one number, 18 mole per gram or something like that. But when we are trying to, because when you will be in some interview and this kind of thing, you're whether you are smart enough to catch the problem, or sometimes your presence of mind will be examined in this way. That I've just asked you what is the molar mass, and you should answer this 18 gram only, not 18 gram per mole. Okay, just some
Okay.
suggestions. Okay, now if you do
It's
this, this is
48.6 kilocalories.
48.6 kilo calorie. So this is this. So there are two options here. Which should be correct option for W? Let's W.
W should be negative, no?
Yes, because this is PdV.
Expansion process. Expansion process.
Yes, this is PdV, and V is increasing, and pressure is constant on 1 atm, and V increases, right? For steam, V increases. So this is W, it is minus PdV. So this is P, this is also positive, this is also positive, this should be negative. So that's why this is this one. Okay, clear? This is easy problems, because you in your exam this kind of problems will be asked probably, because there is not that much big derivations will be required. Okay.
And the last tutorial problem I was going through, that week 12 only, those derivations were huge.
Because that is huge, because this is the last they want you to practice that many problems, so that you will be prepared, right?
Yes, but sometimes they are using that SBPT thing, that mnemonics one. Sometimes they're using Jacobian. I got confused.
So week 12 or week 11?
12.
But if you follow my last live session, there I have discussed in greater length this SPTB and Jacobian, all those stuff. And also, if you follow the week 11 lectures, that is quite handful.
Oh, I haven't seen that.
But please follow the week 11 lectures. This is quite interesting. I have listened to those lectures, and those lectures are quite good.
No, lectures I have seen. I'm going to the live session.
Okay.
Did not get time.
Okay. Anyway, let's see this problem. Problem number 5 says, a thermodynamic cycle is a series of steps that ultimately returns to the beginning point. Compute the total work performed around the thermodynamic cycle of quasi-static processes in the figure below. The figure is starting from point A, and where the pressure is 100 atm, and V volume is 1 centimeter cube, starts from there, and then it has reached B, where the pressure is 300 and the volume is fixed. This is what is this pressure? What is this process called? A to B, where V is constant.
Isochoric process.
Isochoric process. Now B to C, this is isobaric, and the volume changes
Same.
from 1 to 2, and then again isochoric, then again isobaric.
So
Now
step 1 and step 3 does not contribute to any work.
exactly. So what will be the work performed around the thermodynamic cycle?
Step 2 and step 4 will only contribute.
Yes.
So here is a catch. The graph is shown in ATM centimeter cube and the answer is in kilocalorie
Yes. So you have to change the unit.
units.
There is also there is wrong. It should be calorie. I have calculated it. It should be calorie.
In exam hall, these type of mistakes I made before. So I
Yeah.
did not change the unit. I just saw the amount, I mean magnitude, and I just put that. Like
That is quite cardinal sin. You have to visit the. You have to watch for the units, because these are interesting. Man, means you are a chemist. Let's say if I say that your weight is 50 gram, you will take offense of that, right?
very much.
Very much. So, and also, like, since we are observers, right? Because if you do sciences, you have to be observer. You have to observe things from with greater details or minute details. So from those things, this unit thing is very interesting, because have you heard about the magnetic field? To increase from few
Yes.
teslas to from 0.1 tesla to few tesla, one one generation of scientists spend their life to do those things. And
Yes,
also, like,
I read about them in class
yeah,
12.
yeah, also like,
Faded memories and all.
yeah, also like the when we reduce the temperature, the cryo engines and all those stuff, when you reduce the temperature after 5 Kelvin or something like that, if you want to reduce it, for every millikelvin you have to invest crores of rupees, millions and
That
billions
I
of dollars. So that
in
is,
cryogenics I have
yeah,
read.
so that's the thing. Okay, just let's solve it.
So B to C is pressure is 300 atm and volume change is 2 minus 1 1. So 200, 300 atm centimeter cube
Okay.
plus D2A is negative. No, that one will be negative minus 300,
Yeah.
and that step 4 will be positive because volume is
Volume is
compression.
compression is dying, so there will be work will be positive, right?
Yes, so minus 300 and plus 10 is 0. No need of.
Zero.
No, 100. Sorry. 100. So minus 300 plus 100
So
minus
that's why
200.
it is always important to do those things not verbally but mathematically.
Yes.
Do this. So this W is W3, W2 minus W4, or like not minus, plus. So W4 is P1 dV1, and it is P2 dV2. So for this is 300, this is 100, and this is of 1. So this is minus 300 times 1, then minus 200 times minus 1, and this is in atm centimeter cube. Now if you, sorry, this is, I have done the same mistake, this is 100. So if you do that, this is minus 300 plus 100 atm meter cube, and it is minus 200 atm meter cube. Now 1 atm meter cube is equal to 0.0242 calorie. Now if you multiply that 0.0242 calorie, then you get minus 4.84 calorie, right? So this all will be calorie. This is the correct option. Okay. Okay. No problem so far.
No.
Okay. Quickly. This is just statement. Quickly tell me. Is it visible?
Yes, yes.
Which of the
It's a bit
following
small, but it's visible.
Which of the following let's read the question for Gaurav. Which of the following quantities depend on temperature? Option A, partition function. Option B, Boltzmann constant. Option C, energy levels of a system. Option D, average energy of a system. Gaurav? Hello. Gaurav, are you there? Okay, Sadakata, you say. Tell me the answer.
Partition function.
Okay. Any other option correct?
Oh, so it is multiple choice, multiple select questions.
That is not there. So I'm just saying.
The energy level of system, which kind of system? They got confused here.
No, energy levels of system, how can it be temperature dependent? So energy levels of system is totally dependent on the system's
Energy.
intrinsic features. So like there are energy levels that is possible. With temperature just changes its state from one to another. Energy levels are it's there. It is depend on the configurations and all those things.
Then average energy can be the thing.
Should be right.
Yes, because the 3/2 kT or
Yes. And all those stuff,
internal energy also
as there
depends.
is one thing that's minus del U is minus del beta. Beta is one inverse temperature of ln Z.
Exactly.
So I
So
have
this type of question can also come. I
yes,
like
I have solved
in
this
MSQ,
problem.
right?
Yes, I have probably solved this problem previously.
Oh, this is a repetitive question.
I hope so. So Z partition function is summation over Gi to the power minus beta EI. So here this beta is kBT. So this is temperature dependent. And average energy E is written as minus del beta of ln Z. So there is also temperature dependent. That's why option A and option D. Okay. Should I proceed to the next question?
Yes.
Now this should be interesting. You were not there for the previous session, so I will first ask you to solve this, then I will solve it. So the first question says, given that entropy U is equal to 2 square plus 4 plus v square, these SV are the thermodynamic variables, this entropy and volume. Calculate the inner enthalpy H with a function of P and S using the legendary transformations. So tell me, what is the answer?
So here V changes to P and S remains S. The third one should be the case, no? I'm talking about the option.
No.
I'm doing option test
I
in that.
want the complete. How are you
Okay.
doing it? This
Okay.
is just like guessing thing. Here
Is
it
it
is.
correct?
It is correct because it is quite simple, right? So you are just writing it in terms of P and S, but
It has
in all
no
these
other options.
in all those options there is V and S. So this is not correct, right? So option C is correct, but I want the process to follow. I want the process to calculate it from the scratch. And because if there are two options like that, then you will be in full trouble.
Yes, yes,
So
yes.
I don't want my students to learn those things. Half knowledge is dangerous.
Yes. Just give me 1 more minute. I'm solving
Yeah,
it.
yeah, yeah.
So here we need to change the variable v.
Okay.
So applying legendary transformation, we can write that u minus del u del v s n at constant
Yes,
into
yes,
v is equal
yes.
to u plus pv is equal to h.
So you are correctly said that since there is changing the v to p, so we are changing v to p. So we have to write p in terms of u and v, right? U is a function of v. Now p is minus del u del v at constant s, right? Now if you write this
Yes.
h u, then it is u, sorry, u plus pv. So we can write u minus del u del v at constant s and v. So if you write that, then u, which is 2a square plus 4 plus v square, then del u del v at constant s is 2v, that is minus p. So v is equal to minus p by 2. Then u can be written as, in terms of p and s, 2a square plus 4 plus p square by 4, and this is written as v can be then h will be then 2a square plus 4 plus p square by 4 plus pv. So pv minus p by 2, so this will be p square by 2, and then 2a square plus 4, so minus p square by 4. So third option. So if you follow my last lecture, there is also one problem. So we can change this u, p, u, g, a and h in terms of any other thing. So there is also, from u we can get h, we can get g, we can get a. Okay, these are only the coordinate transformation thing we have to do, the legendary transformation. Okay, let me go to the next problem. This also you know, please.
Yes, minus k b p i ln pi.
So that's why
This is
they
this
just changed the problem. They said that which of the following distribution has the lowest entropy, so that you have to calculate.
yes, highest we can
But there
just
is also one um, uh, trick to do that.
catch.
Uh, Option B is not possible, right? It has highest probability.
Yes. Hmm.
Let's do this problem from scratch. Then I can.
Option test.
No. Let's do this problem from scratch. Problem. Calculate the problem from scratch. Then we'll get to the, how can we eliminate the task if you have less
Actually,
time in hand. So that's all.
so from the result, we will be eliminating options that
Yeah.
this can happen.
Yeah.
Last one.
Yes. So for first option A, this will be, let's make KB here. So there will be minus 2 by 8, or 2 times 1 by 8 ln 1 by 8 minus 4 by 8 ln 4 by 8 and minus 2 by 8 ln 2 by 8. Option B, KB minus 4 times 2 by 8 ln 2 by 8. Option C, KB times 3 by 8 ln 3 by 8 minus 2 times 1 by 8 ln 1 by 8. This will be minus. Oh, there is 2 3 by 8, so it is quite easy. 2 times 3 by 8. And option D says KB 4 by 8 ln 4 by 8 minus 3 by 8 ln 3 by 8 minus 1 by 8 ln 1 by 8. Now if you what is the value? This value? Hello. Hello. Hi, we are actually solving this problem where we are trying to find which distribution has the lowest entropy. So as you know that to find the
Yes, sir.
okay, so what is the value? So we just new member has joined, so I'm talking I'm just rephrasing the problem. So for the first thing we have just so you know the problem, the formula of this thing. This is minus we have to do this pi ln pi, where pi is the probability for each distributions, and then whatever time we have to multiply with kb, Boltzmann's constant. For the first option, what is the value? What is the value coming?
I forgot.
Okay.
Did not write it.
Okay, no problem. Okay, if you calculate it, you will find this one is the lowest. Why is so? Let's see for this one. You have probably, if you follow my previous sessions, then you can understand. Then if some distributions are equally probable distribution, it has maximum entropy. Okay. And
That
if
law of large number thing.
yes, now here there two distributions have similar same two pairs of set has same distribution, so this will be next, and then it will be this, and this will be less because it has no similar distributions for other events. Okay, so this is the minimum.
Yes. So say in second one, that second highest maxima, that because two pairs had equal energy,
Yes,
that's why
yes,
that came second.
yes,
And third one only one pair.
yes. Probably if you take the value, that will be the same. I'm just hypothesizing this thing. Let's calculate the value. Probably that would be better. uh, so it is coming around 1.213, and this one and this one is coming around 1.25. So as I've said, this is better than this. So that's thing. Let's not go into the algebra, because
Calculations. Yes.
I don't want to invest that much time here. Okay, so let's this is also easy. Which of the following are exact differentials? Tell me the answer.
Second one is absolutely exact differentials, perfectly.
X, Y. Okay.
First one is also zero will come. So all of the above. If two options are correct, third I need not
We
check.
check. We have to check del n, del y, del n, del x. So for first option, del m, del y,
First, second, both to zero will come.
0. Yes. Del n, del x, 0. Second option, del m, del x, 0. Del m, del n, del y. Sorry, del m, del y, 0. And del n, del x, 0. Option 3, this will be del m, del y will be minus cos x. Here del n, del x will be minus cos x. So all of the above, right? Okay.
Yes,
Now,
sir.
option, this is a big question. I want you to attempt. I know this will take time,
This
and
is
in the meantime,
this
I
is
will
by
take.
Jacobian method, no?
Yes, this is why Jacobian method. So in the meantime, I can take 5 or 6 minutes break. Okay. So the problem says the correct thermodynamic relation is given by. So we have to calculate del V del T in terms of heat capacity at constant volume, isothermal compressibility, and thermal expansion coefficient. Okay, I will write the formulas for those. So alpha, this is isothermal, this is volume expansion coefficient, is del V del T at constant P. Isothermal compressibility kappa T is 1 by V minus del V del P at constant T, and CV is T del S del T at constant. Now we have to calculate what will be the del V del T at constant S. Remember, SP T V, we have seen that del V del T del S. So let's do in this way, del T V S, and this will be, I have drawn the figure. So if from the initial to final is upward direction, that is negative, and if from upward to this is downwards, then from beginning to end point this is positive. So this del V del T S will be is 1 by del T del V S, right? We can write it, right? So del T del V S is equal to minus del P del S at constant V. This formula is useful. Now use Jacobian chain rule and solve it. Okay. Hello.
Hello, you were not audible and you did the meeting. I just could not
Okay.
see the
Just
question properly.
okay. I will just check that it's not. Yeah, I have written so many things. Now it's okay. Now it's visible. Now it's
Yes, sir,
visible.
now it is
Yeah.
visible.
So up to what point you have listened?
Nothing.
Okay. So I have said that alpha is coefficient of thermal expansion, which is written by 1 by V del V del T at constant P, and KT, which is isothermal compressibility, it is defined as minus 1 by V del P del P at constant T, and CB, as you know, T del S del T at constant V. Now we have to remember this Maxwell relationship SPTV. So the thing is that del V del T at constant S is equal to 1 by del T del V at constant S. So del T del V at constant S, to formulate that we have to do like this. So let me just change the pointer. So
Inverse
del
of that
T
thing.
TVS means del T del V in the numerator T, in the denominator V, and S is constant. S is constant. So del T del V at constant S, you will be in this way: del P
Del
del
P del
S
S at
at
constant
constant
V.
V. Now sign will depend on if the initial thing starts from if the arrow which is designed as from initial to final, if it is directed towards directed downwards, then it is negative, sorry, positive.
Yes.
If it is
Oh,
upward, then it is negative.
negative.
Now this is just just minus sign I have took here. Okay, now using chain rule and what do we say, chain rule and Jacobian, solve it. Okay, in the meantime I can take some break. Okay.
Okay, sir.
Are you able to do it?
Under process.
Okay, let me solve it. Because I have many more questions to solve. So now if you do this, then del V del T at constant S will be minus del S del P constant V. Now to write it as Jacobian form, it will be S and the constant term will be here and del P del V. Now I want to make ST at constant V. So I will just flip it like this: delta SV delta TV and delta TV by delta PV.
Okay, so from here you will get the CV.
Okay, now this is nothing but del S del T at constant V, and rest thing
Is
as del TV del PV is here.
that why did not we write that del T del P at constant
Yes, now it is can be written as CV
CV by T?
C by T. Now this thing, this T by V and P by V, we need to keep at constant, like V and V should be each in each numerator. So we will just flip two signs. This will be del V del T and del V del P. So if you switch these variables once, this is negative, but we have switched twice, there is no problem with that. Now we will just make minus Cv by T del V del T. We will do this, and it will be del P del T, and then del P del T will be del V del P. Now I will switch this again once, Cv by T del V del T del P del T. Now if you switch it, then it becomes del T del P and del V del P. Now for switching, this will be plus. Now this Cv by T, this is del V del P at constant T, and this is del T del V at constant P. Now substitute del V del P at constant T. Del V del P at constant T is minus KTV. So Cv minus KTV by T times del T del V at constant P. So del V del T at constant P will be alpha B, and then reverse of that. So 1 by alpha V. V cancel out, and you get
So
minus
first option.
Cv KT by alpha V. This is first option. It is quite
So
fast,
that
right? This is the
is
way you
the
can.
absolutely important.
Yes, and it's easy. It is also easy. The chain rule I have. So what is this this differential you want, this differential derivative you want, that
We can
according to that
manipulate things here.
according to that you can manipulate. Okay, let's go to the next problem. This is also quite lengthy problem. It says correct expression for the Joule-Thomson coefficient mu jt by this. So to do this, we will first derive what is Joule-Thomson coefficient. So mu jt is del T del P at constant h, and h is a function of P and T. If you write it that way, then delta h will be del h del P at constant T dP plus del h del T at constant P dt. Now for h to be constant, del h is 0, and if you manipulate this equation number 1, then you can get del T del P at constant h is equal to del h minus, there will be del P at constant T times del T del h at constant P. What I have just did, I just took this del h equal to 0 here and del P here, del h to here, and you can write it like this. Okay. And del h del P at constant and Cp is equal to del h del
So
T.
last line can you explain once more?
This line.
This line.
So if you make del h equal to 0, then del h del P at constant T dP plus del h del T at constant P dt will be 0. And if you take this here, take this in the right hand side, then it will be del h del T at constant P dt is equal to minus del h del P del T at constant T dP. Now this dP you come here, that will make del T del P, and since what is this process? This is h equal to constant, so this is the way. So now we write this way. This will be 1 minus 1 by Cp del h del P at constant T. Okay. Now
Yes.
dH, if you remember this mnemonics, good physicists have studied under very fine teachers. Then we have said that this is positive x, this is positive y, and you have to replace this, we have to multiply with the conjugate variable. So then del H will be dp plus ds. What is the conjugate variable of dp? This is v, and for ds this is tds. So this is the dh. Now if you just make del H del P at constant T, then it becomes T del S del P at constant T plus V. Okay. Now again use SPTV. SPTV. Del S del P at constant T will be this. So del S del P at constant T, this is, so the direction is changing, so there will be one minus sign. This will be minus del V del T at constant P, and if you just substitute it, then it becomes minus T del V del T at constant P plus V. Now it is easy, right? Alpha is,
1 by v.
if you take V common, then it becomes V is equal to minus T 1 by V del V del T at constant P plus 1.
So alpha comes.
So then alpha comes. Let me add one page here. So just remember what will be this thing. So then mu jt del t del p as constant h becomes minus 1 by cp del h del p as constant t, and if you use this expression, then it becomes minus 1 by cp times, so there is one v here, so it becomes, v will be there, v is equal to minus t times 1 by v del v del p at constant t plus 1. And if you just, if you can write, you can write this as alpha, so this will be alpha, but minus sign you can just play around those things. This will be v by cp by alpha t minus 1, right? So the correct option is v by cp alpha t minus 1. Okay.
Yes, sir. So this is a bit lengthy in
Bit
exam.
lengthy, but just you have to play around those things.
In exam, it will be very difficult if we don't get the approach right.
Yes, yes,
We'll be nervous.
yes. Now this problem says a gas contained in a cylinder is compressed from 1 megapascal and 0.05 meter cube to 2 megapascal. Compression is governed by PV to the power 1.4 equal to constant, some kind of process. Constant internal energy. Internal energy of the gas is given by the some function U by 7.5 PV minus 4425 kilojoule. P is pressure. So calculate the change in internal energy. So to do that, we have to find first V2. So P1 V1 1.4 equal to P2 V2 1.4. So V2 by V1 will be P1 by P2 divided by 1.4. Okay. So
Yes, sir.
what is V2 then? V2 will be V1, which is 0.05 times P1, mean half divided by 1 by 1.4. Let me just do this. 0.5 to the power 1 by 1.4 answer times 0.05, it will give you 0.0305 meter cube. So U is 7.5 PV minus 425. So delta U then will be 7.5 times P1 V1 minus P2 V2. Okay. So minus change, we will do that later. So I think final to initial, let's take the P1 is 1 times 0.05, this is 2.
0.03.
There will be minus here plus here,
Yes.
and then if you do the calculations, and this will be all kilojoule, okay, because this is
Yes.
megapascal and this is megajoule right now, okay, megajoule. And if you do that calculations, then it will be minus 0.05 plus 0.0305 times 2. So this will be 7.5 times 0.011. Answer times 7.5. It is coming as 0.0825 megajoule, and it becomes 82.5 kilojoule. So this is the closest option. So tick it. Okay.
Okay.
Okay. This is also quite easy. This is just by seeing the diagram you need to do this.
So dq is 0.
dq is 0.
That means entropy is also 0.
Entropy is 0. So for okay. So for
1, 2, and 3, 4, the line will be parallel to y-axis.
this and this thing will be parallel to y-axis. So option this
All
one
the all
and
the cases they are parallel to
okay.
yes.
So now for dp equal to 0, t is not fixed, right? P, this is isobaric process. So this is not correct.
No.
So now if P fixed, then in ideal gas there V proportional to T.
Yes. So
So
volume
as volume
X.
increases, temperature should increase. So this curve then not possible.
So first one.
So first one. Okay.
Yeah.
So for 223 and 421 isobaric process, then for ideal cycle V should be proportional to T. That's why option A. Okay. Now this one is also just simple problem. Tell me the answer. Which diagram is correct according to the second law of thermodynamics? Note, E represent the engine, R represent the refrigerator, and W represent the work.
First one, obviously.
Obviously first one, right?
Yes.
So first one is correct. This is not correct because you are just sending heat from lower to
Low higher
higher
temperature
without any requiring any work. So this is
is
not possible.
spontaneously it is not
And
possible.
here from lower to higher you are getting some work. So this is also not possible. So this is the right option. Okay.
Yes.
So we need work to send heat from cold to hot reservoir. Okay. Now this, tell me, do this problem.
This one, okay.
I'll write the formula for Cp. Cp is T del S del T.
This one last one, no?
Yes.
This Professor Arnab Mukherjee did in one of the
Okay,
tutorial
okay.
problems.
But we have to
I
solve it.
So we need one Maxwell relation here,
Yes,
SP.
yes, yes. So let me
I
just do it
remember.
then. I will just give you one hint and then you'll. So then del Cp del P at constant T will be del P of
So S by
T
T is V by T, V by
del
P.
S del T at constant P. So there is no constant T. So T can be safely outside, right? Safely outside.
Yes.
So then T is there. It is become del P del S del T at constant P. And you have to use SP T P. Now you can, since these are, you can shuffle the derivatives, right? You can just use
Exact differential.
yes, del S del P
Del P.
at constant T. Now this is just like this. So all are downward, so their relations will be positive. So then del S del P at constant T will be del P del S or something.
Minus, nor minus. Both will be minus, so positive.
Or did
No,
I?
this is alright.
This is all right. Or
No,
did I
V
mistake?
and T, no?
SPT. Okay. Sorry, this is mistake, right? So this arrow should be
Del, del
arrows
V del T.
arrow should be like this,
Ha.
right?
Del V del T at constant P
Sorry. I'm just doing so.
with a minus sign.
This will be like this. So
Ha.
this will be del V del T with a minus sign because this is
Opposite arrows.
opposite arrows. Now use that here. So minus T del T del V del T constant P. Then it becomes minus T del 2V del T2 at constant. Okay. So the last option is correct. Pretty easy. If you know the Maxwell relation, then it is pretty easy. But you need some more
Yes.
practice to those things faster. Okay. Now this. For a gas obeying equation P times V minus B RT, value of Joule coefficient. Use this formula. This 1 minus 1 by CPV minus T. Sorry, here. What is the formula? Minus that will be del H del PT. Okay, so T dB dt P plus V times 1 by Cp. Okay, got my point? No. So here this is minus 1 by Cp del H del P at constant T, and then del H del P at constant T will be minus T del V del T plus del V del T at constant P plus V. Then just replace these things, then it will become 1 by Cp times T dB dt at constant P plus V, right? Got my point?
Yes.
So then mu Jt mu Jt.
So this is Joule's coefficient, no? So they will mu J only.
Okay, this is mu J. So Joule Thomson. So what is mu J? Tell me.
Minus 1 by CV del U del V T.
Del U del Vt.
Minus 1 by CV into del U del V T. And that কি বলে thermodynamic equation of state, we can get the dilute derivative
Yeah.
as T del P del T v minus P.
Hmm.
So just
Okay.
manually solving the thing. I think it will be zero.
It will be 0. Yes, that's true. So mu will be um, minus 1 by Cv del u del v constant t, right? Del u del v at constant t. Now for del u del v at constant t, to do that we need to find, this can be written as minus 1 by Cv, this is t dp dt at v. If you follow my previous lectures, I have written this formula. Then p will be rt minus p minus b. So then do this for me. Do this for me.
This will be R by V minus B
So del p del t at v will be r by v minus b, and
into T minus P
so that will be then t dp dt at constant v will be rt minus rt by v minus b, which is p.
which is P minus P 0.
So that's why mu j will be okay.
Reduced van der Waals, for reduced van der Waals, it will be 0. Yes.
Yes. Okay. Lots of calculations, it seems. Okay. Now this is easy. Tell me, what should be the option? Tell me. The problem says consider a system whose three energy levels are 0, epsilon, 2 epsilon. Energy level
Last
epsilon
one.
is twofold degenerate and the other two are non-degenerate. The partition function of this last one. Last one. Why last one?
Third one.
Right.
Six. Q
Third
is
one.
equal to third one,
Tell
it
me.
seems.
Tell me. How can we write Z? Z is this way, right? Gi e to the power minus beta epsilon I.
Yes, so for the twofold degenerate state, so
So
degeneracy is 2.
1 plus 2 e to the power minus beta epsilon plus e to the power minus beta 2 beta e epsilon. Now it can be written as 1 plus e to the power minus beta epsilon by square, right? So you are absolutely correct. This should be the option. Okay,
Uh,
good. Now this one, tell me what should be the option. Do it for me.
Give me 1 minute.
Hmm.
C by 3.
C by 3. Yes, correct. So qx is cx, and average of x will be x qx dx. So this will be 0 to 1 cx square dx. So c by 3. This. Okay. Now this probability thing is coming.
This I will tell.
Yes.
I'm a little bit weak
Let's.
in this, but I'll
Okay.
try this.
What is the probability of drawing two S's? S's means A in two random draws without replacement.
The replacement we are just putting the thing back.
No, we are not
No, we are
replacing.
not putting the.
Yes.
We are not
From
replacing.
a full
So,
deck of cards. It's very easy.
so
Just solve.
yeah, I'll do. I'll do. Two random draws.
Hmm.
That means their and probability will work.
Yes.
So first one will be there are four aces total out of that 52.
Hmm.
So first one will be 4 by 52 into 3 by 52.
Yes.
3 by 51, sorry.
Yes.
So that one will be 12 by 52 into
Hmm.
51. I don't know what.
Yeah, you are correct. So first draw, the probability will be 4 by 52. That is 1 by 30. For second draw, since you have just drawn one SS, so second three will be 4 minus 1 divided by 52 minus 1, because one card you have just replaced, you have just drawn, so they will be 51. So they will be 1 by 17.
0.0045, first one.
Yes. So the probability will be 1 by 13 times 1 by 17.
This type of question gives me confidence.
Yes. Probably we have discussed many more problems of probabilities. You can refer to
Yes,
the,
yes.
because probably we were absent in one or two classes. So just refer to those problems. Okay. Now solve this problem. So to do this problem, since these are energy levels are uniformly spaced, so this is the spacing epsilon, which is 3.2 into 10 to the power minus 20 joule. So there will be 1, then next will be to the power minus beta epsilon, next will be to the power minus 2 beta epsilon, and so on so forth. You can write it as e to the power minus beta e, sorry, n beta e, where n comes 0 to infinity. So this will be, just let me write it, 0 to infinity e to the power minus n beta epsilon. So this is a geometric, infinite geometric series, right?
Yes.
So this is z, right? So this becomes
Yes.
1 by 1 minus, this is the coefficient. What is the coefficient? E to the power minus beta e. Every time that is being multiplied. So this is the beta partition function. Now what is the possibility of epsilon equal to 0? That is 1 by z, because 1 means e to the power minus 0, that is 1. 1 by z, e to the power minus 0. So 1 by z, that means 1 minus e to the power minus beta epsilon. And beta is, so beta epsilon is 3.2 into 10 to the power minus 20 divided by, beta is kb, kb is 1.38 into the power minus 23 times 300. And that becomes, if you do these calculations, it becomes 0.9996. Sorry, 19 less.
Second last line, can you tell once more?
Which one? This one? So probability of finding at any energy level, that is actually written as how? E to the power minus beta epsilon by z. Now for epsilon equal to 0, it becomes 1 by z when epsilon equal to 0, right? That is what I am doing.
So here z is equal to the 1 by 1 minus e to the power beta, which is that comes into numerator.
And if you do that,
So, okay.
and that is
So
the
that
since that is the probability, so that is the fraction of molecules will be there. Okay.
so here that geometric mean, infinite geometric mean
Yes, that
series
is required.
comes.
Yeah. Okay. Now you tell me which statistics will describe the density of electron in copper metal?
Electron.
Electron follows which distribution?
Electron is an indistinguishable particle, so it will follow Fermi Dirac statistics.
No, indistinguishable. Bosons are also indistinguishable.
Sorry, I mean with half integral spin.
So this is fermions, half
With half integral spin.
spin.
Yes, actually. I have to be more specific.
This is Fermi Dirac. This is also very easy. Just this is a theory.
Which
Which
are
of
the
the
following
following?
statistics?
Yeah, tell me.
Respond to the Fermi statistics.
So I'll give you
Second one.
second one. Yes, I'll give you one information. AI will be Wi divided by exponential of alpha beta epsilon divided by a constant a, and this a is equal to 0 for max MB statistics, for 1 FD statistics, for -1 Boson-Einstein statistics. Okay, so this is the Fermi statistics, so it will be this is MB, this is FD, this is P. Okay. Now this is, tell me this problem.
Again, this Jacobian.
This is very easy. We have just solved it. I have just reversed the thing.
Del S del P V. अच्छा.
So this is del P del S at constant V, right?
हाँ.
Let's go to the beginning problem. The
I
problem at the
forgot.
beginning.
I'm very bad at remembering
So,
things.
but we have to remember some things. So del P
Yes.
del S at
In this
constant
one,
V
this one.
will del T del V at constant S. So just
Alpha T by CVKT.
so this becomes, so we know, refer to the problem number 10, I will say there, but I can solve it, right, very easily.
Yes, but it is time consuming.
This is the last problem, so we can solve that. So
Then we can.
del P del S at constant V. So there is so let's make it, this will be delta PV delta SP, right? Then again delta PV del P del V. So I'll make it and del S del T. So let's make it delta TV, and this will be delta TV delta SV. Okay, now it becomes delta PV delta TV. This becomes del T del S at constant V. Okay, now here the alpha, what is alpha? Alpha is 1 by V del V del T at constant P. KT is minus 1 by V del V del P at constant T, and CV is del V, T del S del T at constant V. Okay, so
Yes. So this is like some mental exercise.
Yes, like this. So
This should not be given in
let's make it,
exam.
let make this Vp at constant t. Okay, so we can write like del p t del t v, and then again, so we have del p v del p t and del t del s constant. Now we will just interchange these two, v and t. So if you like, we will interchange v and t. Okay, that will induce one minus sign. So this will be minus del pt del vt. Now for this we will to double change, so there will be no problem. Del v del p
Signs will get
del
cancelled.
t p l, and del t del s as constant v will be t by cv. So this will be t by cv,
It will be reversed, like
and
unlike previous.
yes, this will be del p del v at constant t and del v del t at constant p, t by cv. Now del
Del
p
V,
at constant t will be minus of that will be v by kt,
V by KT, and this one will be V alpha.
and this will be v alpha. V by kt or kt by v?
KT by V, I think.
No, 1 by
Uh,
kt, 1 by ktv,
1
right?
by KT V, yes, yes, yes,
And
yes,
this is
yes.
v alpha, this is t by cv.
Because V must
Yes,
cancel
so this will be alpha t by
by
kt cv, alpha t by kt. So option,
I'll just memorize this.
yes.
I think this is going to come.
Okay, so this is the end. So
Yes, madam.
I will just take 1 minute. Just okay. So thank you for everyone for being with me for these 12 long weeks, and I hope that I have I I could solve some problems for you. I could be in some help for you, and hopefully probably for the next any different course I will be there for next semester, and all the best for the examinations, all the best for the certificate examination, and keep learning, keep improving. And so for now, signing off, Dibyendu.